Over to you, Michelle.
Okay, thank you. Good afternoon, everyone. Thanks for joining. And I hope you find some interesting information. And anything that I haven't covered, please just let me know, say in the chat, and we can follow up at the end, or we can come back to you after, or whatever works for you. So I will, excuse me for a few minutes as I'm switching back to the presentation and back to me to show you something. So I'm just going to share my presentation now with you.
And sorry, something I did forget to mention. At some point during the webinar, Michelle or myself will ask you a question, and the first correct answer into the chat box will win a prize.
So can everybody see the screen? Can you see the screen, Gary?
I can see the screen, and now if you want to focus on content, it won't be grayed out anymore, which will make it nice and big on your computer.
So I'll get going. So start this. Obviously, my name is Michelle, and I work for DWK Life Sciences. I'm not sure if you're all aware of DWK Life Sciences, but we're a global glass manufacturer and a supplier of plasticware. We've probably got over 100 years experience glass blowing. Our key focus has always been on our premium brands, is always been on quality and safety. So manufacturing products that are safe in use and good performance, so that the customer doesn't have to think about things like that. So what I'm just going to share first with you is, obviously we have got manufacturing sites on a global level, but where I'm based in Stoke-on-Trent in Staffordshire, and that's where one of our factories is. So I'm just going to share now just a quick, it's only a 2-minute video just of one of our glass blowers at work. So let me just stop sharing this and then share. So this is sorry, let me just start. That's why. Has that not started? Sorry, I'm trying to get, can you see the screen? I'm trying to.
It's playing, it just seems to be a little bit slow, that's all.
But it seems to have stopped again. I don't know, that's been playing all the time when I've play. Is that just froze?
Yeah, we might have to leave this video, I think.
So sorry about this. This is one of our glass blowers at work. Is one of our skilled glass blowers. So our factory in Stoke-on-Trent actually deals with, we do glass manipulation. So at the minute is making a quick fit item. Obviously, a lot of the traditional methods are still done. There's still a lot of hand blowing, and obviously as COVID restrictions ease and people are nearer to Stoke-on-Trent, I'm sure that in this year we might be able to organise with SLS some visit to the factory to actually see these glass blowers, because this is a real skill. Some of them still do it by hand, some do it by the foot control. So I just thought it'd be interesting to see, but I don't know if it's a presentation mode or what's happening for that we can't show this video. So I do apologise for that. That's always running trials. So as much as everyone might not know our company, DWK Life Sciences, you will probably all know our brands. So PYREX, Quickfit are our premium brands. Azlon is our plastic. We've got MBL that has a range of volumetrics and the reagent bottles, and our mid-range Razotherm range. So they're our brands. What I wanted to speak to you about was just some points about PYREX and Quickfit and plastic. So I just want to start with PYREX. So obviously the brand is a little bit unique in the fact that it's, you know, probably most households know the name just because of the cooking, rather than, you know, as much as a technologist and a scientist would. Just to give you a little fact on that's probably relevant now when we've all gone through a big global vaccine, but in PYREX made history along with Jonas Salk's revolutionary polio vaccine when he was looking for vessels and you know, glassware to be able to store these big volumes. So never more relevant than it is today, and we're still supplying on the global vaccine. So that's just a little bit of a, you know, you don't think of PYREX as being part of that history. I don't know if anybody know the name where PYREX comes from, but it's actually Latin and it means fire king. So you know, at the start of the railroads in the US, this was a game changer really to make this thermal resistant glass. So PYREX beakers and tubes, and the reason I picked these two, because when I want to discuss PYREX and explain some things to you about process and why there is a difference, is because these two are heated more than any other products within the lab. So safety always begins with the quality of the glassware. So, you know, these key factors in, you know, that are taken into consideration. You know, not all glass is manufactured the same. And when I mean not all glass, I'm not talking about soda, or I'm talking about the category of borosilicate 3.3. So, you know, there is things to consider: the raw materials that are used, the way it's produced. I mean, you know, you have to think about when you're considering what glassware to buy, you know, quality has to be, I know price is a big thing, but quality obviously helps with your decision. You know, you know, the way it's made and the quality actually contributes to its working life. And that's what we want to make sure, that you're not replacing things as often as you do with some products. So, you know, we all know that glass is very chemically inert, so there's no chemical within the school environment that would eat away at glass. Obviously something like HF would, but then obviously you would never have that in a school. It's got excellent thermal properties, and hence why it's a really good product to use. But there's other quality bits that you don't notice. You know, why do we spend so much and you know, monitor every process? And that's for a longer life cycle, graduations that last, and hopefully less breakages. So for example, a PYREX beaker, it's made in, you know, we have a large number of tests that we control, you know, during the manufacture of this. The quality is constantly manufactured, and I just want to come out of this to stop sharing, just to show. This is a PYREX cut in half beaker. So unfortunately, what I don't have, because they've all broke, because there were two, is the other brands. What I'm going to do though is get some other brands ordered and get our factory to cut them in half. What I'm going to do is then send them on to all the SLS sales team, so they've got examples of this. And I will use them and show them at some of the workshops that we've got planned with SLS during this summer.
So we used to, I think he sent us some a few years ago, and we took them to all exhibitions, and technicians really liked it because until you see it cut in half, it's very hard to tell the difference. And yeah, my cheaper glassware broke. I still have the PYREX one at home.
Yeah, I know. I've still got this, and all the others just broken. You know, it's too dangerous to touch with the edges. So I just want to, you know, why do we make in certain ways? Well, we make it so that it's better for the user, for the end user to use, and that's why. Not, you know, again, you know, what's controlled, the rim profile for a mechanical strength. Just for example, if you get a chip in your windscreen, that's a mechanical stress, and it might not chip, it might not break in the next month, but it you know, temperature changes and certain things could eventually get it to crack. So the pouring spout, again, you know, this is for precision pouring, so that you don't ever get runs down here, drips onto your bench, or it just dripping out. So again, that's something that we monitor. But one of the key things we monitor is both the base and the even walls. So why do we do that? Well, we do that so that the product lasts longer for the people using it. You know, you want even temperature control. You know, you want to make sure that it's even distribution of heat. You haven't got hot spots. So this is why, you know, this is vital. Again, the base. So what you want is a flat base. Of course you do, just when it's on the bench, but also you want that flat base for the maximum contact for heat transfer. What you don't want, if that's uneven, you get a hot spot. And what a hot spot does is it gets heated, and certainly gets heated over a few times. You could get the base to fall off, you could get cracks. Obviously, the whole thing breaks and cracks, and you get spillages. So again, it's, you know, this is all designed to make sure that it's safe in use for when you're using it. There's obviously different ways that people make borosilicate. You know, how the raw materials, or they might make it from tubing that makes it slightly different. It still comes under the category of borosilicate 3.3, but these safety measures, some of them may be taken out for costs. One thing we do is, as I said, we constantly monitor through the whole process. The tank is operated 24 hours a day, 7 days a week. And actually, we knock that down after every few years and rebuild it brick by brick, which is the cost of millions to do that every year, to ensure that, you know, everything that's being produced is of the highest quality. And the last thing I wanted to say was the graduations. These are actually fired onto the surface of the glass, which then gives a permanent fusion, which means when they're going in the dishwasher, cycle upon cycle, or you're just washing, or you don't get this fading or this coming off that you do with sometimes other brands. So, you know, that is actually a technical know-how to ensure that that's a permanent fusion in the glass.
I think most of TSMs have had a customer call them and tell them they've washed the beaker and the graduation just washed off, and it wasn't PYREX. But yeah, we have had that comment before about other brands.
It's just, again, it's just the safety. It's just the manufacturing, the way it's manufactured, and obviously we're trying to do this so that it's safer and its use. And when you're using the product, you've always got graduations. So again, it's another technical know-how. So I just want to go back to my presentation. So apologies for the slowness in my transfer between two things. So one other point I wanted to mention as well, that we seem to get a lot of, we hear about, is filter flasks. So we hear that, you know, when you're trying to put tubing onto the sidearm, you know, sometimes there's, not everybody, this is general now, I'm not, you know, people are cutting themselves, or there is a lot more accidents in that respect. So we do recommend for a safer way is to use a plastic connector, and I will show you this a little bit later on with the Quickfit. And also another point that we get raised a lot is, breakages or on clamping. What we'd always say is, wherever possible, try and distribute the weight evenly. So as you can see in this volumetric flask, try and pull it further down so the weight is evenly distributed. When you're using Quickfit, try and move it as far away as you can from actually the joint to take that stress off it. I know that's not always possible. When you're dealing with something very small, it's more difficult. It is more difficult to do that, but where possible, and it just obviously clamp slowly and reduce the weight. It's just another tip. So Quickfit, some points on Quickfit as well, just to explain about. So this was founded so we pioneered the jointed glassware in 1934. It was actually an assistant chemist that was sort of trying to put some system together, and that was experimenting. And he'd been experimenting for a while, and it actually caught the interest of the Royal Society for Chemistry. So that's how then, with collaboration, just discussion, how it actually came that we manufacture on a large scale as we know today. So that's just some information on Quickfit. I don't want to keep feeling like I'm talking at you, so I've just put this picture up. So the first person to give the full name of this, I think Gary's offered some voucher for SLS.
Yes, they can have a £10 voucher, and the answer is 2 words long, to give you a hint.
And there's a bonus point, and we will send a large box of biscuits to your prep room for where this is used.
It's a 2-word answer. I've seen a couple of answers, but yeah, you need both
the full name and first one to do it, and then there's the bonus point for where this would be most commonly used. And it is something that is produced by us as well, so that gives you another.
I've not seen the right answer yet. Lots of people are saying condenser, which is correct, but there's a different word that goes at the front. Water still, yes, it is part of a water still. So
somebody's got a bonus point there.
Someone's got the bonus.
So that's point. The bonus point, yeah.
I think the first person to say it was water still. I think it was Lucinda Wright. Oh no, that was Emma Hawkey. So I'll write your name down, Emma. So, you've won the bonus points. And
we'll send something as well.
Has anyone got the correct answer yet, though? Because I have to scroll down. I'll be honest, I never got the correct answer when Michelle asked me this during our practice. Like everyone else said condenser. No, there's no correct answers for the voucher. So, okay.
But it is a condenser. It's just a
coil condenser.
A coil condenser
would have been the correct answer. So yeah.
And to see that coil is glass, to actually see how that's made on our factory is amazing. And actually the fact that you can see the flexibility within that is really, not everybody might find it interesting, but I think when I see that being made, it's so interesting. It's so thingy, oh my God, that's just been hand blown, and it's really good how it's done to be even. We have a machine that does it, somebody blows it, and it's, yeah, good to see. So I just wanted to talk about Quickfit. So the first thing I'll say about Quickfit is it does not need grease. I know probably the technicians won't. I think more of teachers sometimes that tend to put grease, but you shouldn't need grease. Obviously, if you were doing this in a large scale industrial, you know, your grease could actually cause contamination to your experiment. You know, it's actually manufactured to the, you know, no joint seizures, and I know that does happen, but it's manufactured to avoid joint seizures. It's, you know, watertight, gas and vacuum tight. So what I want to do now, I just want to try and show you. I'll stop sharing a minute. I've just got a pear-shaped flask here, and obviously what's unique about Quickfit, and again, features basing on safety and the longer lifespan for you, we actually do a two-way grinding process, which is unique to the Quickfit brand. So if you've got any different jointed ware in your prep room that you can look at after your feel, we diamond grind and then we powder grind. So if you put your finger inside any of the socket and then try a different brand, you will startly feel the difference. What we also do that's a bit unique to Quickfit, we do this rounded profile, rim profile. So why do we do that? Why is that beneficial to you? Well, it also obviously gives you additional mechanical strength. So, and also it also protects the socket when it's being used under vacuum, again protecting both user and the lifespan of the product. Now, all our Quickfit is badged with the socket and jut cone on there. So this is manufactured in our factory in Stoke. So if this was made 5 years ago, and a lead bead condenser will be made in 2 years' time, they will be fully interchangeable with no grease. So as I mentioned earlier about the screw thread connector, again, lead bead condensers are a key one when you're doing distillation for your tubes. Again, you know, undo the screw cap, put your tubing on, screw it back on, and then take that off to take the tubing off at the end. It will, you know, instead of putting the pressure and it potentially could hurt yourself and breakage. So that's why we always say, where possible, when you're putting tubing, it gives a safe, secure tube into the glass. So
the point about not needing grease is very good as well, because you know, as with any product, other companies come out and try and copy, and there is some jointed glassware from other people, but I know you do need to add grease for them to get a proper seal, and they're more likely to break as well.
I mean, we make a PTFE seal, and sometimes people buy them because they can mix and match and make the seal better. Now, with using other products. Now, a joint, a 1423, is fully interchangeable. So if you buy another brand, it should fit. It's the same socket, but what we can't guarantee is that it'll be watertight, airtight, gas tight, because we haven't made them. We know that our joints and sockets are together. So I'm not saying they won't fit, I just can't guarantee everything. Another thing we recommend is joint clips. Again, the spring-loaded, that it just makes it safer. It's just safer handling, safer connection. These are color-coded to your joint, and we do them in polypropylene and we do them in PTFE if there is actually, you'd feel better with a higher temperature. So they're both available. And the one thing I wanted to just mention is the socket and the joint. How, you know, a lot of you are very experienced and using them constantly, but there might be some, I don't know everybody who's on this call, there might be new lab technicians and also people who have worked specialising in say physics for a long time and not really been in the chemistry department. So what people call, sometimes this is called a B-length socket. Most Europeans is a B-length socket, and people sometimes say B14, but actually the socket or the size is 1423 or 1926 to 2429. It's two numbers. So the first number is the diameter and the second number is the length. So when you're putting a cone into there, and I know a lot of you know this, it has to be the same size. But Quickfit is you know, a variety of components that make up different assemblies. And a bit like if you had a bag of Lego, you could add to it, or if you lost some, you could just replace. If you've got something with a different size and most of your jointed wear is one size and you've got a couple of things that like, can't use that, rather than buying all new things, you can use a reduction adapter or an expansion adapter. So if everything you've got, apart from some coil Liebig condensers, they say this, you've got some spare Liebig condensers 1926 and everything else is 1423. Just make sure the adapter, the cone, is a 1423, and then the socket on top is a 1926 to fit your condensers that are different size, and that will all be fitted, airtight, and work without replacing lots of things. So I just wanted to, you know, if you've got any questions on joints, or please, you know, just let any of the SLS people know and they can refer to us if they need to. So I just want to go back to the presentation. So plasticware, that's another thing that we get asked questions on. So plastic has become, over the years, it's become more, you know, in the last 20 years, we use a lot more plastic than we did. And obviously it is an alternative for glass in certain things. I mean, off the top of my head, three key things to me are cylinders. Cylinders are a volumetric item. So our cylinders are the same tolerances as glass. And again, they're a volumetric item, but you can't heat them. You don't heat volumetric items. So again, you know, it's less, you know, you can use them and the storage is easier. So it's a good alternative to glass. You've got, you know, in some cases, you may be able to use acrylic PYREX instead of glass. That's another alternative. And then another alternative is delivery tubes. So we have, we originally did this because I think this was brought to our attention by a school technician who said, is there an alternative from glass? Now, a lot of people prefer glass and use glass. This is just an alternative where people might not want to bend their own, or they might be worried they're a bit fragile. So these polypropylene delivery tubes are a good alternative. Again, we do them set sizes, and then we do them with straight tube, and that you can make into your own. So you'd raise them up above a Bunsen burner and you gently manipulate into the shape you wanted. I wouldn't recommend that once you've put them into the shape, your desired shape they're going to use, that you keep doing that, because that's not good for them. But it is something like, if none of the shapes are right, there is a straight shape, and I've bent that over years. That's my sample I've had for years. So it's just some information for you. So what do we have to consider with plastic? Now, when we're working with glass, as we've said, very thermal resistant, you know, it's very chemically inert. The one thing, it's got no expiry date, you know, it's really a good versatile product. One thing it does, nobody's yet got unbreakable glass, it does break. But with plastic, there's various things. It can discolor, and it can discolor over time, and it can become brittle. So, and both of those then, you know, it's shortening the life. It's not meant to last forever. And what can make this happen? So you've got to think about, when you're using plastics as well, you've got to think, right, what am I putting in there? What's the temperature of that? What could I use? Obviously, do I need something clear? You know, transparency, that's another consideration you have to think about. And one of the key things is chemical resistant. And do I need to autoclave it? So that's just, these pictures just show you, you know, polycarbonate bottle discolored and that's polystyrene with a with a crack down because it's become brittle. So this is a range of different polymers, from PMP, PET, polypropylene, and polypropylene is probably the most common you would use in the lab. But again, you know, what's the temperature that I can put something in there? You know, is it good for freezing? You know, can I autoclave it? And this is just a snapshot to show this. For example, you know, a lot of chemicals are sent and delivered in HDPE because it's got a good moisture barrier. You know, HDPE is better for me for freezing than polypropylene, but obviously polypropylene is really good for different chemical resistance, and also you can autoclave it. And then obviously there's, when I'm buying something or when I'm thinking about what do I want with the transparency, you know, you've got polycarbonate bottles, PET bottles used a lot in media, in water testing. You know, we sell a lot of PMP plastic to food manufacturers because what they don't want to have in their you know, they want calibrated products, they want volumetric items. What they don't want is it to be glass, so they want an alternative, but what they do want is that transparency. So PMP again is clear. Once you go to polypropylene, it becomes more translucent. HDP a bit more so, till you come to PTFE, which is just white. I mean, I've got here as an example a PMP cylinder. It's a volumetric cylinder, and the transparency is very clear. If I've got a water glass here with some water, you know, I think it might be the light on here that's off there, but it's very clear against if you put that up towards say a wash bottle that's LDP, you can see the difference between the transparencies. So just for some information there. And what we are having done is these, I don't know if anybody have seen them over time, these handy A5 laminated cards. Now, we haven't got any at the moment. We're currently having them printed, and these will be available. As soon as these are available, we're going to send them to the SLS sales team, who can pass on when they're out and about. And also we will have them at some of the workshops in the summer if you're ever attending any. Now, this is just a snapshot to show you, but obviously they're really good. They fit in the lab coat, they can go on the notice board, they can be wiped down, and it's just a quick snapshot of like, is this, can I put this chemical in this, you know, and it's out. This is a snapshot. The full list is not exhaustive, but it's the most things we've asked for. And on the back of the card is just some other information like, you know, microwavable. Can I autoclave it? You know, what's the recycling code? What's the maximum temperature I can put in? It's just a quick guide for you. So they will soon be available. And, you know, we will make sure that the SLS sales team have a number of these to pass out. So just want to show you this little video of a wash bottle. Now, wash bottles, as we know, are a great, easy, safe way of dispensing solvents. I don't know if anybody can see what happens after two different wash bottles are. So you can see the spillage on there. So I want to just show you, can you unshare? So can you see me now, Gary?
Yeah.
Just so what I've got an example of two wash bottles. So, you know, we all need, you know, vapors build up and we need a release. So what we have is this unique drip lock double two-way valve that both, once you've dispensed, stops the dripping on the bench, but also gives a release of the vapors, so the vapors release, so there's no build up there, so it's not dangerous. And obviously the ease of squeeze, what you want to be doing is easier. we have this in two different styles. So we have the integral, which again, the membrane filter is in the cap. I don't know if you can see this. The membrane filter is in the cap so that the gases escape there. And it's personal choice. I just wanted to show you. So if I was either cleaning this or dispensing into this, I would probably go for the classic style, and that's choice. But if I was putting something or trying to clean and I had some solvents into a little pear-shaped flask, to me, rather than trying to bend this in, I just think these are just easier. So again, we do both for the use of the user, and it's certainly just personal choice, really. Another great safe item are these lids, these silicone lids, and I think these are a great sustainable way of covering containers. And not only that, covers all lab containers, but also you've got these color coded that you know, if you've got you just want to identify something, you could use color coding. So we do them in 3 colors. So again, I think that's just another really good, smart way of accidental spills.
Are the different colors different sizes? So the question
No, what it does, so I'll just show you as it comes in a pack. So I'll just let me stop sharing there, Gary, good question. So they come in a bag of 3. And each pack is the same colour, so you can't have a mismatch of colours, but there's 3 different sizes within that, and there's obviously 3 colours available, but one pack is 3 colours. But they're great for a number of things, not just the lab. I mean, these are just great, these silicone lids. So just another safer option.
Just to let everyone know, if you go searching for that on our education website, you won't actually find it today. We're going to add it to there, but if you're interested, email your rep, because we do have access to those silicone lids.
And I know I'm going over now, so we've got the last few slides. Thank you for your time. It's just some general information. And again, this is trying to cram everything in and give you some key points in half an hour. So just some general information. So obviously, when you're manually washing, and again, I think we've said this number, we you know, if possible, use a plastic core brushes that have the soft, non-abrasive bristles. You know, abrasive cleaning or brushes, you know, or scouring pads really shouldn't be used because they can scratch the glass. And again, it's about getting the lifespan of your glass. Another key one is obviously when you're manually washing, and I think the diamond in my ring is so small to see, but you know, the rings can score the glassware as well, so that's just something to be aware of. And that's why we say in dishwashers, we don't recommend the laboratory dishwashers, because we recommend laboratory dishwashers, sorry, my apologies. The domestic dishwasher tablets that we use are generally a little bit too abrasive. But that's, and also we don't recommend prolonged soaking in water. We don't know what area that people live. There's some very hard water areas, and you know, we say don't prolong that as more than you have to. Heating, I think I've mentioned a lot of this. Really, the biggest thing you need to, for safety and taking care, is when you're working over 150 degrees C. You know, heating and cooling should always be done in a you know, controlled manner, really. Bunsen burners, you know, we recommend no localized roaring flame onto the flask, no over enthusiastic student, which sometimes you have. It's try and diffuse that flame so that the even distribution of heat. Again, glassware, microwave, of course it's microwavable safe. We all use dishes in the microwave. Just making sure that liquid in there is microwave absorbing, and just check if there's any components are polypropylene, of course, can go in the microwave, and obviously PTFE if you've got something, that's fine. So if using a hot plate, obviously just make sure the plate's larger. What I'd say on also what you could use on some experiments is, you know, if the solvent is a low boiling point, you can actually use a sand bath on a hot plate, or you could use a heating mantle if you didn't want a flame. And last but not least, you know, as I said, we manufacture Quickfit so that there is hopefully no joint seizures. But ultimately that does happen. It does happen because, you know, various reasons, the experiment, somebody's got over enthusiastic, something's boiled over, and, you know, so just never force it, which I'm sure none of you ever do. You can use penetrating oil. You know, use that in immerging lukewarm water with a washing detergent, and obviously you can run under the hot tap and try and loosen. Probably a lot of you have tried a lot more other methods that have worked. I'm trying to just give you the safer methods for releasing your joints so that there's no accidents as well. So that's it. I don't know if anybody's got any questions, but I do thank you all for listening and for your time.
Yeah, I'll just stop the recording now.